So can we talk about progress in Kuhn's model? Can we say that there is a coherent development in the history of science towards better and better theories? Can we say that we actually improved on previous theories? Well, the issue, as I said earlier, is not as simple as it may look. Of course, we all agree that quantum physics is a how can I say, an improvement on Aristotelian physics. No one questions that. Oh, indeed, quantum physics allows us to do many more things than other theories in the past. So in this sense, we can say that there was a progress. But Kuhn says we have to start talking about progress in a new way. Whereas Popper, for example, claimed that we have a progress because successive theories, successive hypotheses approach the truth in better and better ways. So there is a progress towards the truth, meaning towards a true description of reality. In Kuhn's view, we have to do away with the very notion of truth. And that is why, I believe at least, that is why there is an actual clash between Popper's point of view and Kuhn's point of view. They're not simply complementary to one another. They see things, they see the nature of the scientific enterprise in a very different way. Kuhn says in the very last pages of where is that of the structure of scientific revolutions, actually the last 2 pages of the book, he deals for the first time in the book, in the whole book, with the idea of truth. And he says, it is now time to notice on page 170, the book is made of 173 pages. It is now time to notice that until the last very few pages, the term truth had entered this essay only in a quotation from Francis Bacon. And then he said, so we talked about the progress, so-called, of science, of the nature, of the structure of scientific revolutions, without ever considering the idea of truth, or true descriptions of reality, physical reality. The developmental process described in this essay has been a process of evolution from primitive beginnings. But nothing that has been or will be said makes it a process of evolution toward anything. Do we really need such a goal? Do we really need to describe science as a progressive approximation to the truth? Can we not account for, as Popper said, can we not account for both science's existence and its success in terms of evolution from the community's state of knowledge at any given time? Does it really help to imagine that there is one full objective, true account of nature, and that the proper measure of scientific achievement is the extent to which it brings us closer to the ultimate goal? If we can learn to substitute evolution from what we know for evolution towards what we wish to know, a number of vexing problems may vanish in the process. So again, it's a completely different picture. The picture Kuhn is providing is a new revolutionary picture of the nature of science that starts from looking closely at the actual practice of science, either current science or science in the past, and clashes with other, he calls stereotypes, other models for the growth of science that, in Kuhn's eyes, fail to dirty their hands, as he says, with the actual practice of science. They are imposed on history of science, and whatever does not fit the grade, so to say, is simply discarded, not not what Kuhn says to be doing. This is not the end of it, of course. Kuhn received a huge amount of criticism after the publication of the book. In that very colloquium I mentioned, which saw the clash between his point of view and Popper's in 1965 in London, another speaker actually called attention to the fact that Kuhn used for the term paradigm in the structure of scientific revolution in at least 22 different ways. So he described the paradigm as 22 different things. And so Kuhn spent the years following the structure of scientific revolutions dealing with this criticism, not only this, there were many, and he revised, partially revised the structure of scientific revolutions, publishing a second edition in 1970 with a postscript in which he completely abandons the idea of paradigm, but he retains the, well, he abandons the terms paradigm, but he retains the idea. He replaces the word paradigm with that of a disciplinary matrix. A matrix that is a set of different items that refer to a specific scientific discipline, hence the term disciplinary matrix. And what are the components of this matrix, which, to repeat, replaces the old concept of paradigm in Kuhn's terminology? Well, there are symbolic generalizations, for example. F equals m times a, Newton's second principle of dynamics, or Newton's or Einstein's gravitational formulas. All these are symbolic generalizations that belong to a specific paradigm or disciplinary matrix and present a different specific aspects of it. Then there are metaphysical parts of paradigms. So, this is the second component of this matrix. For example, using expressions such heat equals the kinetic energy of a system, or entropy is a measure of the disorder of a system. These are metaphysical parts of the paradigm, everyday language expressions that present aspects of the theory. Third component of a disciplinary matrix is trying in this postscript to further develop, further make explicit the scope of the original term paradigm, concept of paradigm. So symbolic generalization, metaphysical elements, and then values. Values such as scope, simplicity, beauty, etc. All these elements are referred to, employed by scientists in their research, even though in different way by different scientists. So they are not as compelling as other elements of the paradigm, but they do indeed play a role in shaping a given time of normal research. And finally, the fourth component of the disciplinary matrix, which is not actually clear whether it's part of the disciplinary matrix or something complementing disciplinary matrices, anyway, is exemplars. And Kuhn says this is actually what I originally meant by exemplars. And paradigm is indeed an exemplar, a model, as I said at the beginning, upon which we model our research. He says, when a physicist studies at university, attends physics lectures, and studies on textbooks, he studies a chapter, possibly in mechanics or thermodynamics and so on, or astronomy. He studies a chapter in the book, and in which a number of examples are present. And then at the end of the chapter, Kuhn says, the physics student faces a number of exercises, of problems. How do we deal does he deal with those problems? How does he come to a solution to those problems? Those problems are specific problems. Problems are very specific exercises. So are not, their solution is not, of course, presented in the relevant chapter. But the physicist is able to solve those exercises, to come up with a solution as soon as he is able to see that specific exercise as an instance of the general example offered in the chapter. So as soon as he refers that specific problem to the more general problem offered in the chapter. And those more general problems, which are provided as models for all subsequent solutions to problems, are what Kuhn calls the exemplars of the paradigm. This was basically the content of the postscript published in the second edition of the structure. It must be said that Kuhn died in 1996 while still working on a book which he never completed, which was meant to be a further revision to this second edition of the structure of scientific revolutions. The book was meant to be published a couple of years ago, then it was not, then there was the pandemic. It was announced for the end of this year. I actually read the manuscript, the typescript of this book, but it's not yet out. And there are indeed some developments, some changes, which Kuhn mentioned in a number of papers published beginning with 1983, a famous paper titled, the paper is often referred to as the CCC paper because it's titled Commensurability, Comparability, Communicability, in which he revises this radical idea of incommensurability as radical incomparability between two successive paradigms or disciplinary matrix by saying that incommensurability is only a local issue. So there are only parts of paradigms that cannot be actually compared. And then he focuses on these last works of his, beginning with 1983 until his death in 1996, only with the semantic, as I said at the beginning, with the semantic, earlier on, sorry, with the semantic aspects of incommensurability. He talks about no longer talks about paradigms, he no longer talks about disciplinary matrices, he talks about lexicons. Theories are seen as lexicon, as vocabularies, so to say, ways of looking at the world and organizing the objects in the world and their relationship. You may remember this kind of discourse in Wittgenstein's when we talked about Wittgenstein's Tractatus, and indeed Wittgenstein's, especially the so-called second Wittgenstein, plays a major role in these later developments of Kuhn's thought. So Kuhn sees paradigms or disciplinary matrices as lexicons, that is, as ways of organizing the objects in the world and their mutual relationship. Incommensurability is like having two dictionaries of two different languages. You cannot really, you can translate a few things, and incommensurability is only a local phenomenon, according to Kuhn in the 1980s and onwards. But there are other things which you have to learn. Scientists practicing, and which you cannot actually translate. Scientists practicing science under two different lexicons, under two different paradigms in the old terminology, need to become bilingual. They cannot fully translate from one another. They simply speak two different languages at the same time, or may learn to speak two different languages at the same time. And finally, what is a scientific revolution? In Kuhn's later views, it is no longer a change of the core of the normal science, that is the paradigm, but it is a change of lexicon. An old dictionary is replaced by a new dictionary, and revolution are seen as taxonomic changes in the ways we organize taxonomy. We organize objects and relationships among objects in the world.